So we're going to end our lesson by looking at a composite figure. That's a compilation of different figures. And it looks like we're going to involve the volume, but let's see what's going on. We have a solid, so this is our solid right here, is composed of a right cylinder and a hemisphere as shown. So here's our cylinder, and you can see we have a hemisphere or half of a sphere right on top. If the density of the solid is 100 kilograms per cubic meter, what is the mass of the solid? Well, now it just sounds like we're in science class. So what are they wanting us to do? They want us to find the mass of the solid. So what is the mass of this? That's not volume. That's a different thing. So let's go ahead and just make a note that when you find, you guys might know this from your science classes already, mass is going to be equal to the density, which we know they gave us that in the question, times the volume. And now, do you see why this is appropriate in this lesson? We're going to find the volume. We can multiply it with the density that they gave us to answer the question and find the mass. So we're going to find the volume. So taking a look at our figure over here, we can see this is a cylinder and this is a hemisphere. So let's find the volume of both of those figures. I guess I'll start with the hemisphere. Doesn't matter which one you find first. But the volume of the hemisphere. Remember, we're going to find the volume of the entire sphere and we'll just divide it by 2. So our volume is 4/3 pi times our radius. So they did not give us the radius. They give us the diameter straight across. But we know to take that and cut it in half. So our radius is 1 meter. So 4/3 times pi times 1 to the 3rd power. We calculate that out and we get a total volume of 4.19. But because it's a hemisphere, we're going to go ahead and divide that by 2. So the volume of our hemisphere is 2.095 meters cubed. We also have to find the volume of the cylinder. So that's from a previous lesson. You guys remember the volume formula for a cylinder? It's got 2 bases. So the volume formula is just the area of the base times the height. But what's special about a cylinder is the bases will always be circles. So the area of a circle, I'll just go ahead and write that in pi r squared, and then we multiply that by the height of the cylinder. So we have already identified the radius of 1. So pi times our radius is 1 squared times now the height is this 3 meters right here. So they did give us the height of the cylinder. We calculate that out and we get the volume of the cylinder to be 9.425 meters cubed. All right, so the total volume of this composite figure, we will just add those together to get a total volume of 11 point, and I'll do a little rounding here, 11.52 meters cubed. All right, now that we have the volume, we can go back and answer the question, what is the mass of the solid? So remember mass up here, we wrote mass is equal to the density times the volume. So the density was that 100 kilograms per meter cubed. I'm going to include the labels because I want to address those here in a second. So I'm going to say kilograms per meter cubed. We multiply that by our volume, which is 11.52 meters cubed. So we will just go ahead and multiply the numbers together. The 100 times the 11.52. That gets us 1,152. But then I want to show you what happens with the labels. You probably have seen this in a science class. I think. Let me know if not, and you will see it. You'll see this a bunch actually. So we take this label right here, and it's going to feel like we're multiplying it by the other label, so times a meters cubed over 1. And what happens is our labels kind of cancel each other out, and you can see that in the result, or at the resulting label will just be a kilograms. So mass has a unit of just kilograms versus a kilogram per meter cubed or meters cubed. Just mass is 11 1,152 kilograms.